Here we will go to discuss about the kinematics and dynamics of the fluid flow. Fluid may be classified as steady and unsteady flows, uniform and non-uniform flows, 1 to 3 dimensional flow, rotational and irrotational flows, laminar and turbulent flows, compressible and incompressible flows. Steady flow means the type of flow in which fluid characteristics like velocity, pressure and density at a point do not change with respect to time. That is called steady flow. So, in the velocity, the fluid characteristics do not change with respect to time. That is called steady flow. For example, flow through the pipe at a constant flow rate is a steady flow. Next one, unsteady flow. It is that type of flow in which velocity, pressure and density at the point change with respect to time. That is, the flow in the pipe is whose valve is being opened and closed gradually. That is called unsteady flow. Next one, uniform and non-uniform flow. The type of flow in which velocity at any point do not change with respect to space. That is called uniform flow. That is flow through the straight pipeline, that is flow through the straight pipe of constant diameter. Okay, that is next one, non-uniform flow in the velocity at any point changes with respect to space. That is in the flow around a uniform pipe, bend or conical bend, that is the diameter varies, the gradually decreases or increases. First in the flow is convergent flow and divergent flow. That is an example of the non-uniform flow. One dimensional flow in the flow parameter as such as velocity function of the time, that is called one phase coordinata. Two dimensional flow in the flow in which velocity is the function of time and two rectangular space coordinata, it is called two dimensional flow. That is another one, the type of three-dimensional flow. The velocity is a function of time and three mutually perpendicular directions. That is called three-dimensional flow. Rotational flow. The flow is said to be rotational. The fluid particles, while moving the direction of flow, rotate about the axis of the center. That is called rotational flow. Motion of liquid in a rotating tank. Irrotational flow. The direction of flow don't rotate about the mass center. Somewhat eccentric from the center of the axis, that is flow above the drain hole of the stationary tank or wash basin. The laminar flow at which in the points taken individually particles do not cross or any other move along with a well-defined path. This type of flow is called straight line or viscous flow. That means it is well-defined path flow through the capillary tube, flow of fluid in the vents and groundwater flow. The turbulent flow means in the fluid particle move in a zigzag manner. High velocity flow in the pipe of larger size. Next one, this is the laminar and turbulent flow. The Reynolds number is less than 2000 in the flow in the pipe is laminar. The greater than 4000 in the flow in the pipe is turbulent. In between, the Reynolds number is in between 2000 and 4000. The flow may be a laminar or turbulent. Compressible and incompressible flow. The type of flow in which density of the fluid changes with point to point. That is called compressible flow. Density is not constant. That is flow of gas through the orifice, nozzle and gas turbines. The compressible flow is only for the gas fluids. The incompressible flow means the density of the fluid is constant. The liquids are generally considered as the incompressible flow. Subsonic aerodynamics. The rate of flow is defined as the quantity of fluid flowing per second through a section of pipe. For incompressible flow, it is may be expressed as volume of fluid flowing across the section per second. Rate of flow usually expressed as per liquid meter cube per second or liter per second. Okay, that is Q is equal to A into V. Q is equal to rate of flow or discharge. A is equal to cross sectional area of the pipe into area average velocity of the fluid across the section. Next, we will go to discuss about that continuity equation. In the continuity equation derived based on the principle of conservation of mass. Okay, conservation of mass. What is meant by conservation of mass? The fluid entering the control volume, the volume of fluid entering the control volume, that is equal to leaving the control volume. Thus, for flowing through all the cross sectional, the quantity of fluid per second is constant. The V1 and rho1, the fluid properties on section 1, and in the rate of flow section 1 is rho1 A1 V1, and rate of flow section 2 is A2 rho2 V2 A2. According to conservation of mass, rate of flow section 1 is equal to rate of flow section 2. That is A1 V1 A2 V2 is equal to A1 V1 is equal to A2 V2. That is called continuity equation. Next, we will go to solve the problem. A 30 centimeter diameter pipe is conveying the branches to two pipes of diameter 20 centimeter and 15 centimeter. If average velocity of the average pipe is 2.5 meter per second, find the discharge of this pipe. Also determine the velocity of the 15 centimeter pipe if average velocity is 20 centimeter. The diameter of the pipe is 2 meter per second. So here one pipe is there, the pipe is diameter of the pipe is 30 centimeter diameter, is divided into two branch. Pipe 2 the diameter is 20 centimeter, pipe 3 diameter is 15 centimeter. In that condition, and also the velocity of the average velocity of the diameter 30 centimeter diameter pipe, velocity of the 30 centimeter pipe is 2.5 meter per second, and 20 centimeter diameter of the pipe, velocity of the 20 centimeter diameter pipe is 2 meter per second. In that condition, you should calculate the discharge of the pipe 1 and velocity of the pipe 3. First, you should calculate the area of the all the pipes, area of the all the three pipes. Next, according to continuity equation, Q1 is equal to Q2 plus Q3. Then Q1 is equal to A1 V1. A1 already we have calculated, and velocity of the pipe 1 is given in this problem. So we have calculate the discharge of the pipe 1, that is 0.1767 meter cube per second. At the same time, we have to find the velocity of the pipe 3. Already we know that according to continuity equation, Q1 is equal to Q2 plus Q3. In this way, we have to find the velocity of the pipe 2 is given, so Q2 also find 0.0628 meter cube per second, equating the substituting all the values in equation 1. From that we can find the Q3, rate of flow on pipe 3. From that, V3 is equal to Q by A3. In this way, we have find the velocity of pipe 3. Okay.